Let's now look at an example to see how we apply standardization to find probabilities for a non-standard normal variable. Here we have the daily number of customers is a normal variable with a mean of 32 and a standard deviation of 4. We want to find the probability that there are between 36 and 43 customers. I'm gonna let X denote the daily number of customers, and so X is normally distributed. The mean mu of X is equal to 32, and the standard deviation sigma of X is equal to 4. Okay. What we want to find is we want to find the probability that 36 is less than or equal to X less than or equal to 43. Okay. Now note that the fact that the mean of X is equal to 32 and the standard deviation of X is equal to 4 immediately tells us that X is not the standard normal. And so we cannot use the standard normal probabilities table to find the probabilities right away. We need to first convert X into the standard normal. Remember that we convert a normal variable into the standard normal by standardizing it, right? And in particular, we standardize by taking the variable, subtract the mean from it, and divide it by the standard deviation. So let's do it here. For this problem, essentially what we want to do to X is we want to subtract the mean of X and divide it by the standard deviation of X. But note that this is an inequality, right? And so in order for the inequality to remain valid, whatever you do to X, you have to do the same thing to 36 and 43. In other words, you're gonna have 36 minus mu X divided by sigma X, and then you will have 43 minus mu X divided by sigma X. Okay. But we know that mu X is equal to 32, right? So this is 32, this is 32, and then sigma X is equal to 4. Right. So we're gonna have 36 minus 32 divided by 4. This middle part here, according to our formula, becomes Z, right? And then we're gonna have 43 minus 32 divided by 4. That means that we have the probability that 1 is less than or equal to Z, less than or equal to 2.75. Okay. Now 1 here is not known as the Z value associated with 36, and then 2.75 is the Z value associated with 43. Now, you have turned the problem from finding the probability that 36 is less than or equal to x less than or equal to 33 from up here to finding the probability that 1 is less than or equal to z less than or equal to 2.75. We know what to do here, right? This is going to be equal to, this is a second rule when it comes to the standard normal probabilities table. So this is going to be equal to the probability that z is less than or equal to 2.75 minus the probability that z is less than or equal to 1. And these are values that we can look up from the standard normal table. So let's go ahead and do that. So we have 2.75 and we have 1. So the probability that z is less than or equal to 2.75, and then we want the probability that z is less than or equal to 1. For 2.75, you want to go to row 2.7, look under column 0.05, and so if you do that, you find a probability of 0.9970. This is, and then for 1, you want to go to row, so 1, first off, 1 is just 1.00, right? So you want to go to row 1.0 and look under column 0.00. That gives you a probability of 0.8413. So you have the first term being 0.9970 and the second term being 0.8413. If you do the math here, you get 0.1557 as the answer. In other words, the probability that there will be between 36 and 43 customers is 0.1557. So in this video, we looked at how we apply standardization to find probabilities of a non-standard normal variable. The idea is whenever you do the standardization, if you do something to x, you have to do it to other values in the inequality as well.